laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to be looking at an example of how to use PyCharm's debugging environment to debug a Python program. And if you recall from our last video, PyCharm has quite a few features in its debugging environment that are going to be helpful for us. These include things like breakpoints, which allow us to pause the execution of our code at set points, as well as the ability to step through code one line at a time, a variable explorer to allow us to inspect and even modify the value of variables as it's being executed, as well as some ability to view the call stack. That's sort of the different order that functions are called and which functions call each other. And remember, the way we get into the debugging environment is by clicking the debug icon, or Shift F9 on Windows. And this icon is located right by the Run button in your PyCharm interface. Now, the first thing we should talk about are adding breakpoints, and this is one of the most helpful things that a debugger provides. So in PyCharm, to add a breakpoint, you simply click on the line number next to the line that you want to add a breakpoint to. When you run in debugging mode, this means that the execution will pause at this line. But keep in mind, breakpoints only have any effect when in debugging mode. They're not going to do anything when you run your program using the normal run icon. Also keep in mind that you can't add a breakpoint to just any line. It has to have some sort of statement on it that the program can actually pause on. This won't work if you try to add a breakpoint to a comment or a blank line. When we run our code in debug mode, we get the debugging window rather than just going right to the console. That's what would happen if we were just running our code normally. And this debugging window is how we're going to access all those features I mentioned. For example, down here we can see the variable explorer. This contains all of the different variables that have been declared, their types, as well as their current value. This also allows us to modify the values of these variables if we wanted to. Next up is this button to restart the program. This works just like the restart button when we're normally running. It causes the whole program to stop and then restart from the beginning. We also have the stop button, just like we would when we're normally running our program, and it does the same thing. It stops the program and then it ends our debugging session. Next up is the resume button. And what this does is it resumes the program and keeps running it until it hits the next breakpoint or the end of the program. Remember, if we have breakpoints set, the debugger will stop at those points. So this allows us to jump to the next breakpoint. Next up are our stepping controls. And there's 4 different controls here, but they all have a very similar function. The first one is step over. And this executes the current line of code that we're on and then moves to the next line without stepping into any function calls on that line. We haven't gone too much into functions yet in this course, but when we start defining our own, it will be important to decide whether we want to jump into those when we are debugging or if we want to just skip over them and assume that they work correctly. So it could matter if you're defining your own functions, then you might want to care about maybe if they're working correctly or not because the bug could be in them. Whereas if we're pretty sure those functions are already good, then we probably want to step over them. Next is step into, and this will move into function calls on the current line to debug it line by line, just like it was normal code. Next is step into my code, and this will skip any external libraries and only step into functions that you wrote yourself, which can be a bit more useful because usually you trust that libraries have their functions made correctly. And the last one is step out. What this does is it runs the rest of the lines in a function if you're currently in a function, and then it pauses once the function is done and you return. There are a few other features here we should mention. The first is the console. We can still access the console, so we can put in text when there's input needed, and we can also see what output we're getting. We just click on there to get to the console. When we want to switch back, we just click on threads and variables. The other thing to note is there is a pause program button. So if you have a program that's currently running, you can hit pause if you're running in debug mode to stop it, just like if it were hit a breakpoint. One thing I'll note is usually our programs run fairly fast, so trying to rely on smashing that pause button is probably not going to work for you. So it's usually much better to hit a breakpoint, unless you're stuck in an infinite loop or something and you want to pause and see what's going on. Let's now switch over to PyCharm and try out these tools to debug a real Python program. Okay, here we are in PyCharm, and we have a program loaded up, and this is the program we're trying to debug. And let's see what this is supposed to do. So this program should find the number of prime numbers in a given range. For example, if we put in 1 and 10, it should try to count how many prime numbers there are between 1 and 10 inclusively. That means it includes the 1 and includes the 10. However, it contains 2 logic errors. We want to try to figure out what those errors are. Now, there's a few ways we could do this. We could just try to go through it line by line and see if we figure out the error. We could use rubber duck debugging and try to explain each line to a duck and see if that helps us figure out what the error is. Or we could try adding those print statements in to help debug it. But we want to do something a little bit more powerful in this case. We want to use the debugging environment that's built into PyCharm. So before we get started, we should probably explain what prime numbers are, just in case you don't know. So prime numbers are natural numbers that are greater than 1 that have no positive divisors other than 1 and themselves. So they can't be formed by multiplying 2 smaller numbers. So as an example, I have a few written out here, such as 2, 3, 5, 7, 11, 13, 17, 19, and so on. So to give an example of what this program should do, if we gave it the range 2 to 19, that would be inclusive, it should output 8. There's 8 prime numbers between 2 and 19 inclusively. And we can check that. That's 1, 2, 3, 4, 5, 6, 7, and 8. Now you might think, well, we could put all the prime numbers in a list and then figure it out that way, but that's not how we're going to do it because we don't know all the prime numbers. We want this to work for a really large range. So we're actually going to do the calculations of trying to figure out if that number is divisible for all the numbers in that range. And we have the program to do that here, but the issue is it's not working right. And we can see that by just running it normally. So we're going to give it the values 2 and 19, which should result in an 8 like we saw before, but we are getting 10, which is incorrect. So we want to use that debugging environment to try to figure out why. But before we start debugging this program, we should just take a quick visual inspection to see what it's trying to do. So first, we're getting 2 inputs from the user, start and end, and these are going to be the start and end of the range, and they're supposed to be inclusive. So they should include the start and include the end if those happen to be prime numbers. We then have a count here. This is going to store our count of the number of prime numbers we've seen so far. We're going to start that at 0. And then we have a nested loop structure. So this outer loop is going to loop through our range. So it's going to start at start and run up to end. And it's going to refer to that value that we're currently on in the loop as num. So if we put in 2 and 19, like in this example here, it would start at 2 with num equal being 2, then 3, then 4, then 5, then 6, then all the way up to 19. We do have a check in here, an if statement, for if num is less than 2, but this is only checking if we put an invalid starting point. So if we put in a negative number, or if we put in a 0 or a 1, just going to restart this loop without running any of these lines, because we know there are no prime numbers under 2. Next is the most interesting part. And this is going to check if the number is prime that we're currently looking at. So if we're running this the first time, it could be 2, then 3, then 4. Whatever the number is, we want to know, is num a prime number? And we're going to do this by a proof of contradiction. So we're going to start out by assuming that the number is prime, and we're going to try to find a number that it's divisible by evenly that will prove that it is not prime. If we prove that it's not prime, we are going to update that to false. And the way we're going to do that is we have a second loop that's going to run from 2 all the way up to, but not including, num. So this would mean, let's say we had num equal to 5, it would run for 2, 3, and 4, but not 5. And inside this loop, we are going to be checking if num is divisible by that number for the loop I. So the first time, if num was 5, it would check, is num divisible by 2, then is it divisible by 3, and then is it divisible by 4. The way we're checking that is using the mod operator. So in this case, it would say is num divided by I. So let's say it was 5 divided by 3. Does that have a remainder? Mod will return that remainder. And then we're checking, is that remainder equal to 0? If the remainder is equal to 0, that means it to be divided evenly. That means that number, num, is divisible by that number I. If we find any numbers less than num that are divisible, that's divisible by, that means it's not prime. And that means we found a contradiction, so we set is prime equal to false to represent that this is not a prime number. And as soon as we've found a contradiction, we don't need to check any more numbers, so we can break and exit out of this for loop. Then this if statement down here is checking if it's prime or not. If it's prime, it should add 1 to the number. But like I said, there are 2 logic errors in here. So 2 of those lines I described don't actually do what I described. And we could have caught that with rubber duck debugging, but in this case, we're going to try using the debugger. And the first thing we should do is set some breakpoints. Remember, breakpoints tell the debugger to pause at this line. So a good general first place to start is probably before the loop and at the end of the loop. So we're going to say we're going to pause on line 20 and we're going to pause on line 40. Now, when we want to run in debug mode, we don't just hit run, we hit debug or Shift F9 on Windows. And you can see it's running, it seems somewhat normal. And that's because we're currently haven't reached a breakpoint because we are inputting the values for the range. So we're going to say we're going to start at 2 and we're going to run to 19. And now we hit a breakpoint. So before running this line, we've paused and we have loaded up the debugging window. And in here, there are some interesting things. We kind of broke this down a bit in the slides, but we can see we have the 2 variables that exist so far, start and end. And these are what I input in the console. You can see the current value of start is 2, and the current value of end is 19. And we could do things with them here, like edit their value, things like that. But right now, we're just trying to find that bug. One of the first things we can try is resuming the program. So when we click resume, or F9 on Windows, what will happen is it's going to run the rest of the code, including these loops, until it gets to line 40, and it will pause again. Let's see what happens. Okay, so it ran all this code, and then it paused on this line here. And we can see our variables have been updated, and these give us some clues as to what's going on here. So we can see start and end are still 2 and 19. That's expected. That's what we input, and we don't really change them at all. But we can also see that prime count equals 10, and that's the result we are returning, and that's incorrect. So something's going wrong in our calculation of prime count. The other values we can see are I, which was the index for this inner loop, and it left off at 2. So last time this was run, I was 2. And then the other thing we can see is num. And num was the index of this outer loop here. And we can see that it left off at 18. And that's a bit of a clue there. Remember, this is supposed to be inclusive. Remember, 2 and 19 inclusive. And this is supposed to run through the numbers in the range, going all the way from 2 up to 19 inclusively. And we can remember that ranges start at an inclusive value, in this case 2, and their end point or their stop point is exclusive. So it doesn't include that end number. So if we have 19 here, which means we're only running up to, but not including 19. And that's why the last value was 18. If you're wondering what's going on here, this is the inline debugging. So as you're running in debugging mode, you'll add what looks like comments beside variables to tell you what their current value is, at least where their current value is as of the breakpoint you're currently on. So the first issue might be with this loop here. Remember, it's only running up to 18, not up to including 19. But there's something else going on. We can see that by actually correcting that. So we're going to hit stop, or we can also hit stop down here to stop. And then we can try to fix the code. So in this case, we know it wasn't running all the way to the end because it said it was only going to 18. So we'll add 1. And we'll try running that in debug mode again. 2, 19. It stopped here. We can see our end is 19 like it should be. Let's resume. And we get jumped down to the end of the program. And now we can see prime count is still 10. So remember, there was 2 logic errors. Something still isn't right here. But now we can see the loop is running till 19. Num is 19. So now we want to explore a little bit more deeply what's going on here. There's probably some error inside the loop that jumping over it doesn't really help us with. So I'll hit a resume again just to end it. And we can see we do get the incorrect result still. So let's try to find that other logic error. In this case, we're going to run it again. Do 2 and 19 again. But now, instead of hitting resume, that will just jump us down to the bottom, we're going to use these step features, step over and step into. What they'll let us do is run this one line at a time to try to get an idea of what's going on in the code here. Remember, step over will go over a function, so it won't go into a function to explore it, while step in will go into a function. However, we don't really have any function calls here, at least not ones we defined or aren't built into Python. So whichever one we use in this case, it's still just going to go one line at a time. For more complex programs where we do have our own functions or using third-party libraries, there is a difference here. But for here, we'll just go step into, which is also F7. So we hit step into. So that means we only go one line. That brings us to the start of the for loop. We can see a variable changed, and that was prime count. So prime count got set to 0, and we can also see that in line up here. We'll step in again. And now we've entered this outer loop. And we can see the outer loop is starting at num equals 2, which makes sense. That is our starting point. And we are at this if statement here. And it's checking if num is less than 2. In this case, it's not. So we'll probably see this jump over. This was a simple check to see if the number was negative, just so we can deal with the user inputting invalid values like that. So we'll go step into, and you can see we didn't run continue because this wasn't true. So we jump to the next line. And this is setting is prime equal to true. This is going to keep track of if we think this number is prime, and then based on what happens in this loop, it's going to update that to true or false based on whether this was a prime number or not. So we run that line, and we can see prime is now equal to true, and that is in our list of variables. So now we're going to enter into this loop. So in this case, what's going to happen is we're saying for I in range 2 to num, but not since num is 2, that means that this range is empty. It would be 2 to 2, so there's no numbers in that range because the end is exclusive. So in this case, we're not even going to run this loop. We're just going to jump over it. We get down here to is prime equal false. In that case, it doesn't enter it. That's interesting. This is where we add to our count of primes. But you can see it didn't get increased. It's still at 0. And 2 is a prime number. So maybe there's something odd going on either in this loop or in this if statement that isn't setting it correctly. It's not adding it, even though 2 is prime. What's happened since we got to the end of this loop? We restarted the outer loop. And we can keep stepping into. And we can see because this outer loop is started or restarted, that the value of num has incremented by 1, 2, 3. And we're going to do this check again. It is not a negative number. It's not less than 2. So we're going to go over it. Is prime equals true. So we're setting prime to true again. And this time we're actually going to enter into this inner loop because we're saying the range is 2 to 3, which does have a single number in it, which is 2. So inside this loop, now that I is equal to 2, we're doing a check here. The idea here is that we're going to go through every number less than the current number we're checking for primeness and seeing if it's divisible by that number. We're doing that with the mod operator. So we're saying number, which in this case is 3 from this outer loop. If we divide that by I, which is currently 2, but it's going to go through every single number less than it. If that is divisible by that means it equals 0. It means it has no remainder. If we find something that's divisible, that's less than that value, it means it's not prime. And so we found 2 numbers we could times together to get that number. Or you could also see it as it means we could divide that and have an even result, like no remainder left over. It divides evenly. So if we do find such a counter example, we then set is prime to false, and we break out of that inner loop. So if prime equals false, that means that this is not a prime number and we shouldn't add it to our total. Whereas if we never set is prime to false, that means we haven't found any counterexamples. So we've proved that it is prime. In this case, it is going to have a remainder. 3 divided by 2, we can see I is equal to 2, num is equal to 3. So 3 divided by 2 does have a remainder, which means it's not going to equal to 0. So in that case, we don't enter the if statement, we jump over it. And that causes the loop to restart. But now we're out of the range. So the loop's going to exit. And we go down to here and check, is prime equal false? In this case, prime is equaling true, which is correct. It is a prime number. But again, we didn't add 1 to count. That's odd. 3 is prime, so prime count should have been incremented. Instead, we restarted the loop again. And since the loop was restarted, num gets incremented to the next one in the range, which is 4. Again, 4 is not less than 2, so we keep going. We set prime to true. And now we're going to go through this loop again to try to see if we can prove that it's not prime. So in this case, we're going to look through every number in the range 2 to 4 exclusively. So it's going to be 2 and 3. And we're going to see if any of those are divisible. Is 4 divisible by any of these numbers? So the current value of num is 4, and the current value of I is 2. So what we're checking, if we divide num by 2, does it have a remainder of 0? In this case, it divides evenly, which means we enter into this if statement. We then set is prime equals to false. We found a counterexample. So is prime down here has been updated to false, and we hit break, which should get us out of this for loop, even though we haven't completed it. So we jump down here. In this case, it's false. 4 isn't a prime number, so we shouldn't add it to the count. But we did enter the if statement, and we did add 1 to our total count of primes. That's odd. We shouldn't have been adding 4. 4 is not a prime number, and we didn't add 2 or 3. So let's go through one more time. In this case, we restart the outer loop, so it's equal to 5. 5 is not less than 2, so we're going to jump over that. Is prime equals to false, or is prime equals true rather? So we're going to update the value of prime to true. Remember, it gets set to false that last time, so we're going to reset it. And you can see is prime has been updated to true. Now we're going to run this inner loop again, but this time it's going to run from 2 up to, but not including 5. So 2, 3, and 4. We're going to check if 5 is divisible by 4, if it's divisible by 3, and if it's divisible by 2. They're going the other way. We start checking with 2. So we enter in this loop. We can see that I is equal to 2. And we're going to check if 5 is divisible by 2. It's not. So we restart the loop because we got to the end of the loop because we didn't enter the if. I is now equal to 3. You can see that here. So we're going to see is 5 divisible by 3? It's not. So we restart the loop. We update I to 4. Is 5 divisible by 4? It's not. So we start the loop. And we're at the end of the loop because we got the end of that range. And we didn't find any counterexamples, so 5 is prime. And that is correct based on our examples up here. But we get to this if statement again. And in this case, it is prime, so we should add to the count, but we don't. We jump up again. And I think we've been through this enough to start seeing that the error is definitely here. So what we're going to do is we're going to just resume the program, run the rest of it, and we'll run that last line and get the incorrect result. So based on our debugging, the issue happens here. When it is prime, we're not adding to the count, and when it's not prime, we are adding to the count. And that is due to this line here, which is the logic error. So it shouldn't be is prime equals false. We only want to count if it is prime, because we are trying to count prime numbers, not prime numbers. So we could change that to is prime equals true. And this would work. We could try it out. And we get 8, which is the correct number. But it's a little bit more correct in terms of style to just say is prime. The reason why this works is prime's already a Boolean value, so it's already going to return true or false. So this should work as well. Try it again with 2 to 19. And we can see we are getting the number 8 now. So we were able to identify that second logic error. Now, a good thing when you're debugging your programs or testing them out isn't just to check them with two values like this and assume that it works correctly. Instead, we should try a few different values. So let's try some more. So let's say we'll start at 5 and we'll run up to 25. We get the number 7. Since there is 7 primes, we should confirm that that makes sense. So we're starting at 5. 1, 2, 3, 4, 5, 6, 7, and then we'd get 24, then 25, and it would stop. So 7 is correct. There are 7 prime numbers between 5 and 25. We also test it out for a silly answer, like maybe -1 and 10. And we can see it's working well for that. So -1 would be down here, and we'd get 1, 2, 3, 4. So there are 4 numbers between -1 and 10. Now, there are a lot of areas we could improve this program. We could do some better error checking in case, for example, the end came before the start, or maybe the user input like a text like duck instead of a number. And there's also some rooms for optimization. So there are ways we could optimize this, but now we've at least removed the logic errors. But let's also take a look at an example of being able to edit values. So we'll just start a new Python file. Let's call it test or testing. So in this case, let's make a variable. We'll call this hello. Also add a number. And we'll add a print line here. And maybe we'll make it a little bit interesting and add something at least to num plus equals 10. So we can set a breakpoint right at the start and give this a run in debug mode. So we're at the first line. Nothing special so far. We stepped into the next one. We can see hello equals hello world. We'll step to the next one. We can see num equals 123.45. See that in our list of variables. And we can see that we just added 10 to num. So it's now updated to 133.45. And now we are paused right before we run this print line. So if we did want to edit a variable live, for example, before this print statement happens, we could click down here and click set value. Then we could edit it to whatever we want. Say goodbye. And we could change this number too. Set the value to 1337. And then we can resume the program. And we can see instead of writing out hello world and then 133.45, we got the variables that we edited it to. So this debugging environment can be quite powerful because it not only allows us to see the current value of variables, but we can also modify and play around with them. We can also do things like ask questions by inputting expressions. Let's run this again. And we'll step into a few lines so we get some variables. So here we can evaluate an expression. So we could ask a question like, is num greater than 0? And you can see we have a result true down here. Could also ask a question or see what would happen if we said hello. And then we called the upper method on it. You can see the result would be it in all uppercase. Or we could try something like hello at index 2. And we can see the result is an L. So we also are allowed to run expressions right in here to sort of evaluate things while we're currently running the code. So again, it can be quite powerful. Stop right now. Okay, so let's switch back to the slides. And we're back to the slides. And for those of you following along in the PDF, I do have a copy of the program here, as well as it's attached to the learning management system, so you can get the raw Python file. I also have a copy with the corrections already made, which is that correction to the range for the loop, so it's inclusive, as well as that correction to that if statement to make sure it's actually checking if it's a prime number. That's all I have for you in this video, but one thing I should stress before we go is that learning how to use a debugger like this is something that's best learned through practice. So I recommend as you're working on those assignments or any examples or anything you're doing in PyCharm, try running that program in the debugger in a few cases. Add a few breakpoints, and try going through your code line by line to understand how it works and see how the state of the different variables change. Also mention that the debugger in PyCharm is a very powerful tool, and it has a lot more features than what we're showing here. So if you are interested, we do have a few links to some tutorials as well as some guides on how to use the debugger that goes into a lot more depth. The key takeaway here is that we can use this to help understand our code as well as to help us find bugs in the code. And that could be very useful for you on assignments. Thank you for watching and have a great day.